Olena Kutsenko is a developer advocate at Ivan. She spends a lot of her time helping people understand Apache Kafka. Kafka is an increasingly ubiquitous and essential part of modern data infrastructure, and it really is an essential technology to understand if you're going to play in the world of real-time analytics, which is what this podcast is about. So listen in as Olena and I talk about the basics of Apache Kafka. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and I'm joined today by Olena Kutsenko. Olena is a developer advocate for Ivan. You may pronounce it Avon, but you'd be wrong. It's actually Ivan. Olena, welcome to the show.
Thank you. Happy to be here.
How did you get into developer advocacy? What was your path to get where you are?
To be honest, it all started back in 80s. My parents didn't have anyone to spend time with me when I was a kid, so they were bringing me to their office. And in their office, and they were software engineers, they had all these old computers, which like right now ancient. And there was one program, Fox Pro. Do you remember Fox Pro?
I am definitely old enough to remember Fox Pro. That's amazing.
So that was kind of the most engaging toy I had as a kid. Later, I had something else, like other games, but that was where I started. And some years later, I was working as a software engineer. And then I decided it's time to move on and start, instead of using the knowledge, but maybe also help others and share the knowledge I have, because I really enjoy doing that. And then I found an amazing company, Ivan. And a year and a half I've been at Ivan, doing all stuff, Kafka, OpenSearch, all different data and things there.
And I've definitely seen you out speaking, and we were just talking before we started recording. You've been releasing some great videos recently. I really love them. So just love the work you're doing. And I want to say, so I also was in the 80s as a kid programming, wasn't a database. So you have a much longer data pedigree. I didn't join the data space until a lot later, like maybe I had teenagers or maybe one teenager. I don't know. It was a little bit later, but that's amazing.
To be honest, it was also like a joke because I was still like 5 years or 6 years old.
Sure.
So it was not exactly that. I knew that to get out of Fox Pro, you need to type exit.
Yeah.
And of course, I didn't speak like English. It's just like, and also I didn't know the keyboard. So you kind of try to find those characters. So
what are these strange symbols that are not Cyrillic on this keyboard, right? That's great. I'm trying to think. There was no data. Like I was certainly aware of Fox Pro, DBase, later Access. Like I was aware of those things, but I always kind of kept them at a distance. I did firmware in my early career. Mm-hmm. Anyway, we are not here to talk about computing in the 1980s. That is a fascinating episode. That's a different episode. We're here to talk about Kafka. So this being the Real-Time Analytics Podcast, there are a lot of technologies that are of interest, and Kafka is kind of implicated in all of them. It always just seems to be there as the modern data substrate. So if you were speaking to someone uninitiated, and maybe that's not very many people right now, but we want to honor those people who maybe don't know what Kafka is, aren't too comfortable with it. How would you describe it?
I think I would start with a scenario, some kind of a use case. And maybe like in some kind of microservices world. Like, for example, Tim, imagine that you have your online shop, or you are going to build an online shop. Mm-hmm. What exactly would you sell actually there?
I would sell, let's just say, antique computing artifacts. So I have these old computer parts and things. Yeah.
Great. So, and then you start building the shop, and maybe at first you're like, okay, I want just to prototype and make sure that we are moving the right direction. And maybe you have a very small team there, and you put it all into a single monolith, like some kind of ordering system, payments, and all that stuff.
I just kind of bang out the code, write the big thing, and
yeah, exactly. It's a bit of spaghetti code, but then you also want to validate the ideas. But then with the time, when your shop gets really popular, you have more customers coming and they like ask for features, and you make like some profit, and you're like, okay, that's time to get bigger team. And then you bring more people, and people like, you have architecture in a spaghetti mode. So like, how about we split it into microservices? And microservices are amazing. However, they come with a challenge.
Mhm.
How exactly we are going to make the communication between those modules? And of course, like when we are talking about systems such as, I don't know, online shop or some different things system where we need this real-time data going through the modules, we just cannot rely on just API calls. We need somehow a system which will be stable even if something like some disaster happens and you then need to recap the data. You need some kind of like distributed system.
Mhm.
This is where the Kafka comes into play. And Kafka allows you, so Kafka is event streaming platform.
Mhm.
So it allows you to transport the messages across those multiple microservices. Like in our example here in the online shop, we have maybe some mobile application where customers put the order and do some actions, and then we have kind of like a recommendation engine or a delivery system or something like this. And then we need to send the data across those systems and reuse maybe some of the data. And we want to do it in a way that we persist the data somewhere for the time being, and then we can reuse it kind of like, I don't know, the process, the flow of the user activities or actions then for recommendations and for deliveries. And Kafka offers that in the middle, like the Kafka cluster has a persistent storage where you can send those records, those messages, and on the other side, those recommendation engine or like other modules can consume and pull those messages and do whatever they need to do with it. So that's kind of an overview of Apache Kafka.
There you go. I love it. See, you used the words in there, event streaming platform, which is kind of the 3-word definition. But if you don't know what that is, you kind of need the whole story there to see how it fits together. You don't have, event streaming platform doesn't mean anything until you kind of already understand what Kafka is. So yeah, I like that microservices story. I've broken my monolith up into pieces. They need to talk to each other, and there's different ways to do that. So like in the early days of microservices, people were just having them synchronously call each other.
Yes.
Mimicking what you did in the monolith, right? When I had to call some other method of some other object, well, you just freaking call it. It's that simple. And so the first step of microservices, well, let's do that call over the network. But that, when, like you said, when something's broken.
And you can't do it because also like sometimes like those calls, like those drops of, like, let's say those are drops of water, right? But when we are talking about event streaming or this amount of data which comes through the system nowadays, it's like it's a river of data. You can't just like do it drop by drop. You really need to make it efficient how it moves through the system.
Right.
And that's, I think, what Apache Kafka tries to solve because we have all that latency and throughput metrics, and we want to make sure that our system is scalable with all of that. Also that it is distributed in a way that if something happened with some of the servers where stores that data, then we are still fine because we replicated the data in other locations.
There you go. If is Kafka a typical question for a newcomer to the space? Is this the same as a message queue? It sounds like you're describing a message queue. Is it a message queue?
So it's not the same. And the biggest difference, I think, is that the brokers, the Kafka servers, they store the data persistently. So it's not only like the data moves, okay, maybe like the river. It's very difficult to find here a good example. But it's like, I like to think about the river, but then it's like kind of the river, but it goes into some kind of a common space where you hold the data, and then, so it's a bit tricky. But the idea for Kafka is that it persistently stores the data as long as you want to store it. It can be for pretty long time, doesn't have to be. But then you can reuse the data. So, for example, for our case with the online shop, you have recommendation engine, but you have also this kind of like maybe analytics. And then you want to reuse the data the same data, but for different purposes. So, and then you can kind of consume the data. You don't truly take those messages away. You go through the messages, but messages are persistently stored and still are staying in the broker.
There you go. So reading, and we'll introduce a term, reading a message from a topic, one of these streams doesn't consume the message. The message stays there.
Yeah, exactly.
Until it gets to a certain age, and you said it can be a long time, and I've seen mostly what I've seen is people don't tend to keep data around in Kafka for very long. It tends to be a week, a couple weeks, a month, something like that. But it can be much longer. I mean, this can be this record of everything. Yeah.
I also don't see a big sense of keeping it forever there, because it becomes quite tricky then to analyze what you have there. So you probably want to move it eventually into some different types of storages.
Well, this is not an episode about Pinot, but it sounds like you're talking about Pinot. Yeah, right. You want to put it either in a data lake or something for real time analysis or something like that. That might be the destination. Okay, so we've got a few terms you've introduced. Broker, that's just a server, and if you're kind of thinking about the architecture or the deployment, that's one of the servers that makes up the Kafka cluster. There are lots of those. They store the actual data in these logs, or these we call them topics.
Mm-hmm.
I want to talk about writing and reading. So if I am an application, we could just say I'm a Java application or Go or whatever, I don't know, something, and I want to write to a topic or read from a topic. What's the API look like for that?
So when you write to a topic, this is what we call producing the data to the topic. And then you have that information. You have plenty of libraries which will help you to do this, so you don't have to reinvent the wheel. And actually, this is probably a moment to mention that Kafka exists from, I don't know, it was 2010, 2009?
I believe 2010-ish, yeah, at LinkedIn.
Yeah, so like a lot of problems are already solved. Like it's kind of not only solved, but it's validated and polished and all that stuff. So you have so many libraries. Like Java is one of the most popular ones, but there is also JavaScript and other stuff. So and then what you do, you take the information which you want to send to the cluster, you package it in some kind of record, and then you send the data to the broker. It's in simple terms, it's like that. It's a bit more complex because, of course, you don't truly send one by one item. If you start sending and you have like millions items per, I don't know, like given amount of time, it will be a huge load on the network and on the broker. So you actually also do the batching there. So you put it into a group of items and you send those items together into the cluster. And this is the producing of the data.
Yes.
And then on the consuming side, so those applications later which need the data, so like recommendation engine, it's like it will actually proactively go and pull the data or read the data. Read is probably a better word here. Like read the data. It will know what was the last message it was reading. So every time, even if it goes down, like, and we have to create like or replace the consuming application or something, it knows where it was. So we kind of, okay, I read till this moment, let me read next and messages. And also like it will fetch those messages, like some given amount of those, and process them on the consuming side.
There are a few really good points in there that I want to dig into. First, on the producing side, you talked about batching messages up. Now, batch can be, in the context of real-time things, can be a dirty word. So to be precise there, that is, the concept of producing, like you said, it's pretty simple. You just write the stuff, right? And there's all kinds of plumbing going on in the library that most of the time you don't have to worry about. But also, if you're sending data frequently, you probably want to send a clump of messages over the network, right? So in terms of the network plumbing, it's going to manage batching and acknowledgements and retries and making sure the messages get there and all that stuff. So there could be batching there, and that's tunable on the parameter on the producer side if you get into that. Now you mentioned something on the consumer. Oh yeah. You said pull or read, and that's a whole thing, the pull versus push model, right? And I remember when I was brand new to Kafka and first learning, it was really surprising to me that consumers pulled data. That seemed like, if this is an event-driven system, you don't want to pull, because again, my early software career was all in firmware, and it's a very similar word but a different vowel. We would say pull, where you just go check, 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 check. You pull, and that's like trash, right? If you're reduced to polling something, either it's a very simple microcontroller with barely any resources at all, or you're just not good at what you do. And that polling was like bad, you know. And it always struck me as weird that Kafka is this pull model, but in fact, it works really well. And
it makes total sense, because also consumers, those know those, like, also computational, they do some computational stuff, so they know better how much they can process of that information in a given time.
Yep.
So you don't want to push it. To be honest, like, when I'm thinking of that, and also, like, I was working as a software engineer, and even now, like, you know, like, as an employee, you don't want to be pushed onto the work. You want to pull what you can do in a given amount of time during the day, and then, like, okay, now I can get the next portion. And if you have, like, too much for me to give, that's your problem. Like, keep it, and I will come later, and I will take it, and I will finish that work. But just like, I am working in my own pace.
Yes.
It has some drawbacks, of course. Like, sometimes, like, okay, so this, what we call consumer lag. It's how far consumers, those consuming applications, behind than the producers. So how long it takes from message from the starting point till the finishing line. Yeah. And then, of course, if the consumers are too slow, then this consumer lag increases, and of course, like, the whole flow becomes pretty slow for the user.
Right.
So,
and there's also, I think, a more subtle thing where if it's a push model, then the broker needs to keep state about who's consuming. Like, it needs to know who to be pushing to right now.
Yeah, true.
And that's a lot more intelligence that gets pushed into the broker. And when I dig through Kafka architecture, I see this principle that the community, or the team that has been building it, has kept to pretty well, which is that the broker stays dumb. You know, the broker is like, he's got one job, and that's to put stuff in a log and replicate it. And then like, that's it.
That's what I like about Kafka. It's like, it's actually pretty simple, the whole design. Of course, like, it's very, we can misuse and make everything working like not as how it was designed, but the whole design principles are pretty straightforward.
Yeah.
And it's actually the power of Apache Kafka.
Yeah. So on the consume side, consumers keep track of what they need next. And basically they ask, they say, they know the last message I read was offset 1,048,576. And they'll say, okay, so give me 1,048,577 or anything later. And if there isn't anything, I guess this is the other bummer about the pull model. If there isn't anything, well, they won't get anything, and they'll have to wait and come back and ask again after some time. And that can introduce a little latency. But if it's a busy topic with messages flowing all the time, you don't usually have that problem.
Yeah, exactly. And I think if there is not anything there, I think it's still like, it's fine. Like, it doesn't get new information, but I don't see, actually, it doesn't introduce latency in this way. It just, we don't have anything to process. Like, so.
Well, what's latency if there's nothing to process? Yeah.
Yeah, exactly.
So, okay. So the consumer is keeping track of the offset, and it's pulling, and that's cool because that pushes the state into the consumer, keeps it out of the broker. And that's another kind of Kafka value, is that you want to push functionality into the consumer, right? You don't want, which is another question I've got when I'm introducing Kafka to people. Why doesn't the consumer code run on the broker? You know, why do I have to move the data? And like, oh, well,
Yeah, I think, like, we're trying to encapsulate the logic and kind of like separate the responsibilities. Like, as a developer or like as engineers, we are responsible to write those producers and produce the data. And then Kafka cluster can be perceived. Okay, we shouldn't really perceive it as a black box completely, because if we don't understand how it works, then we can there are some tricky parts with partitioning there. But also, like, we need to take care the responsibility of producing and then consuming the messages and focus on that. And then we can kind of like give to decide Kafka cluster how it works with data best on its side, and we don't really get involved much there. So
Right.
that's, I see, like, it's just splitting the responsibilities.
Right. And as for doing compute on brokers, I've got a friend who works at Red Panda. Maybe we'll cover that on a future episode. They've got a thing where you can actually push jobs onto the broker. It's an interesting Kafka-like kind of functionality, but that's a big ball of wax, right? You don't want to be putting new processes on the broker if you can help it.
No.
Two other things. You said partitioning. I want to come back to that and have you explain to us what partitioning is. And I want to talk about consumer groups and how you scale on the read side. Because in a system like this, writing is usually cheap. You have a thing and take it, right? Now I'm reading, well, anything could be happening. That could be, I could have a lot of work to do. It could be a lot of like database IO, a lot of writes. It could be a lot of computation. So I want to talk about how to scale on the compute side. But first, talk about partitioning.
Yeah, because this compute side will depend how the partitioning is done. And it's like they influence each other. Like, actually, no. The influence goes from the how you produce data on how you consume data.
Yes.
So when we produce data, and actually, let's talk about the brokers inside, like this kind of this black box, like Kafka, which is not really black box. But so inside we have brokers, and we usually, when we store data, we say we store data in a topic. But what we actually mean, because topic is kind of like this abstract concept.
It's
because
a great one as a developer to think of.
Yeah.
It's this log of data. It's got a name. Love it. But
yeah, because we like to we try to simplify stuff. But on the disks, when we store data, because it's a distributed system, we need to separate and split the topic from one object, being like storing part of the topic on one broker, another part of this topic on the other broker. And then the question is how exactly we are going to cut the topic. Like, we need somehow to decide.
I mean, we're agreeing that we have to because it just might be too big for one server.
Yes.
We're distributed infrastructure, but how?
Yeah. Exactly. And the logic or like the decision, how many, so we need to decide how many, so those parts we call partitions, and we need to decide what data we send where. Let's now assume that like we just go with the built-in mechanism of Apache Kafka. We don't really care about maybe the particular order of message. We just send flow of data and it somehow gets distributed across those partitions. The number of partitions also matters because you don't want to have too many, but also you don't want to have too few. And for the partitioning, so when we decide where the data should go, that's the responsibility of the producer. So the producer will send the records, and it will. We have several mechanisms to do that, and I think that the latest
to determine. So I'm producing. My topic is split into some number of partitions that I've determined by magic. Like you said, it's not obvious. But as a producer, I need to know which partition to put it in because they might literally be on different servers, so I'm setting it. Yeah. Okay. So how does the producer determine that? I think you're about to get into that.
Yeah. So in the past, we were having the round-robin approach, round-robin partitioner. And it's kind of a pretty cool because it would go like you have, for example, you decided that your topic consists of 5 partitions. And it will go like, okay, I sent a bunch of messages to the first one, to the second one, and so on. And then kind of like go around that.
It will always be fair, but
it's not really super efficient.
Yeah.
Also, like this is the moment to say that, we don't send one by one message again. We are actually grouping those messages into, we are buffering those, and then we send those like batches to the cluster. But it's not super efficient. So we change that to use a sticky partitioner. And sticky partitioner will now select the partition, then start accumulating some messages to send there till one of two conditions happens. First one is like if we reach the maximum amount of time which we allocated for that operation. And second one is the maximum size of the batch which we can send to a partition. And then we send the data, and then we select another partition, as a broker. And then we repeat the operation, go on and on.
How about, and we haven't talked about messages as key value pairs yet, hasn't been important.
Yes.
But okay, everybody, if you didn't know, now you do. A Kafka message is a key and a value. So how about the key and partitioning and that whole part of the story?
Yeah. So if you really care about the order of the messages, for example, like in the shop team, your shop of which we are building, when a user makes some operations, for example, puts an object into the basket and then goes and pays for that product, and then we deliver, the ordering of those messages, you can't really do it in random order.
Or that user,
Yeah, exactly.
Because there's lots of users doing it, but like this is a particular customer buying vintage computer parts.
Yeah.
That order matters, yeah.
Yeah. So you want that your, delivery system or something that was like, it got the messages in the right order. And how to ensure that, because like the challenge is when we have a distributed system, we have multiple servers around, like we send and also we split the topic into partitions, so we have a piece of here, piece of there. But then when the consumer starts reading the data, how does consumer know that the ordering is correct? Or actually consumer might not even care about the ordering. Yeah. It just will process what it gets first. And again, we are trying to be very efficient and very fast as how we move in data. So it can happen that the ordering of the events produced by the user will be totally reshuffled. So, and this is not really good. That's why the solution is to send the data, which must remain in the order, to the same partition. And partition is a log file. So when we look at the brokers, it's a bit so if we dive into how the broker looks, inside there are folders and there are files, and each file will be a segment of a partition, and it will be a log file. And the log file is very simple. We write the data one by one there, and it's kind of, if you write the data, the line in that file, and then you write the second line, you totally know that the first one was happening before than the second one. So we can guarantee the ordering. This is kind of inside of a broker. And when consumer reads the data, it can be we can be quite sure that the ordering of the items is correct. But how to make sure that we are sending the data relevant to the single user exactly to one partition?
Yes.
And this is where the key or the keys are playing the role. We not only have a record, for every record, we have a key, kind of extra information. And this key, we will make sure that Kafka makes sure that all data with the same key gets into the same partition in the broker. And that's why the key is as important. Here, for example, for our shopping scenario, we can use user ID, might be not the best, or we can use shopping trip ID, which probably will be better as the key to make sure that the events within single shopping trip will be always in the right order.
Yes, got it. Okay, so we use the message key, and we make that some identifier in our domain, say user ID or whatever that matters, wherever we want to preserve ordering, and then Kafka makes sure that those messages, that key, always get to the same partition. That partition is the thing that's actually the log. Because if you went back, did the round robin, I mean, you're going to have rough ordering, things that are in this part, the later part of the topic are going to be newer than the earlier topic, but you'll never know exactly what order they're in.
Yes, exactly.
If you use a key and a hash-based partitioner, then you'll within a partition, you'll have strict ordering, which sounds like a good thing. Okay, so that's
Yeah,
part.
exactly. I think like it depends on the use case, because not everywhere we need this ordering of the messages. And then if you don't need really a precise ordering, then you probably want to make the distribution of the data across partitions in the most efficient way. And that's what Kafka tries to provide you if you use those sticky partitioner, the current default way correctly.
Because round robin is definitely going to be fair. And if there's a particular user, like if there was a vintage computer parts store and I was like decorating a new house or something like that, I would have a lot of activity. And so my partition might be bigger than the other ones.
Yeah, exactly. I mean, also you won't have like one user per partition. You probably I assume that teams, your shop will be so popular so that you have millions of users. So like you can't really have millions of partitions. Like you can have a lot of partitions, but you shouldn't.
But you shouldn't.
So you probably will have like multiple users, but then some users will be really into, and they will be like ordering stuff like nonstop and amazing. Like we love those customers, but then you have unbalanced partitions.
Right. Final question, and that's on the consume side. So I've got all these partitions and I stand up some new microservice that, I don't know, runs some expensive machine learning model or something. There's a lot of compute. And so just one consumer is not enough. I need to scale that out. So how do consumers scale?
So that's a very interesting topic. So consumers, because we take care of the ordering, you can't have a consumer, or like you can't have two consumers which will read from one topic, because again, then how can you make sure that they kind of coordinate to make the ordering right?
Right. You can't have two reading from a single partition.
From a single partition.
Yeah. We need each other to get those words right. I get them wrong all the time.
Yeah. That's like it's too many words.
Because they would ordering would be compromised if you had two consumers reading from the same partition.
Yeah, exactly. So you will have multiple consumers, but each consumer will be exclusively assigned to one or more partition. So you have a topic and you have, for example, 5 or 6 partitions. And then you can have, if you have a 6 partitions, then you have up to 6 consumers which will be taking care of the data from these partitions. So the number of consumers is limited by the number of partitions you have.
Okay, that follows. Yes. So if I have 6 partitions, I can't have 7 consumers that are doing anything.
Technically, you can, but
one of them will be,
Yeah.
Unless it's like hot standby or something.
True.
It depends on how you want to do all that, but it would be idle because it can't be sharing a partition with another consumer. Got it. That sounds like that introduces, this is a topic for another time, but a whole bunch of interesting questions about how that scaling actually happens and state management, and that's thorny. But the basic mechanism of the consumer group scaling is, you're saying, built in.
Yeah, exactly. And it's also interesting because if producer will mess up how the data is distributed, producer might even not notice that. It just distributes the data, but then it can be like, okay, well, we have one partition which has huge amount of data and the rest are not really busy. But who will suffer are the consumers. So the consequences of bad distribution of data, we will see on the consumer. I mean, we also will see it on the broker side. But I mean, it's kind of funny that producer who actually is responsible for that will not suffer that much as those guys who will have to process the data later. And that's where it's also how do you scale the system? And you have that limitation that, you will have to scale them vertically somehow, the consumers, or find a different way.
Right. And of course, that's an option. You can always scale vertically, but they at least give you the option of scaling. Yeah, to some extent, you have the option of scaling horizontally as well.
Yeah.
My guest today has been Olena Kutsenko. Olena, thanks for being a part of the Real-Time Analytics podcast.
Thank you so much. It was really fun to be here.
And there you have it. If you feel compelled to help us spread the word and grow the Real-Time Analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.